Hello grade 11s and welcome. So today we are dealing with a clock face. So this question says in the diagram below shows a clock face 12 where there is 12 is joined to 4 and 2 is joined to 7 with straight lines A, B and C D respectively. O is the center of the clock face. So O is our center of this circle. So 6.2.1 says if OA or OA where AO and DO are joined, show that A angle OD equals to 60 degrees. So they say if we join OA and OD, we need to determine this angle at the center there. So 6.2.1, we know that a clock has got 12 segments. Let's call each segment X, right, as a popular variable. So it means then we're going to have 12x equals to, we know that the angle around the circle is 360 degrees. So that is 360 degrees. Therefore, when you divide 360 degrees by 12, we're going to find out that x equals to 30 degrees. Right. Therefore, but we need what? A angle OD, which is two segments. A from 12 to 1, then 1 to 2. So those are two segments. Therefore, A angle OD is going to be equals to 2 times 30 degrees, which equals to 60 degrees. And most importantly, we need to indicate that at center. So that is the angle at center, right? And then let me change the color. And then the second question says in 6.2.2, if CO and BO are joined, calculate C angle OB. If CO and BO are joined, determine or rather calculate COB, C angle OB, that angle right there at the center. So 6.2.2, so C angle OB is going to be equals to, so those are how many segments? 1 2 3. So it's going to be 3 times 30 degrees, which equals to 90 degrees, and that is from 6.2.1. we know that from 6.2.1 one segment equals to 30 degrees, right? Now it says hence calculate angle E1. So we need to calculate angle E1. So when I have to slot the 6.2.3 here, 6.2.3. So since these angles were at the center, these two, so then we can say that, okay, we have the angles at the center, but we do not have the angles at the circumference of the circle. Because if we join this line over here, then that is going to help us determine what? Angle E1. Because if you check angle E1 here, is the exterior angle of this triangle CEA. Right, so we need to determine this angle here and that angle over there. So if we determine these two angles, then we'll find angle E1. But we need to use the angles at the center to determine the angles at the circumference, because this angle C here is actually the twice angle of this center, and this center is related to that one. So we're going to say angle A is going to be equals to half of 90 degrees, which is this one. Remember, this angle equals to 90 degrees, which is this angle. So that angle right there, that angle A, that's going to be C angle AE, right, which is denominated as A, equals to half of 90. That is angle at center, right? Angle at center equals to 2 times angle at circumference, right? Therefore, that angle is going to be equal to half of 90, that is 45 degrees, right? And the same with this one, angle C. This angle here is going to be A angle CE is going to be equals to half of what? Of 30. Okay, that was 60, sorry, that is 60, so it's going to be half of 60 degrees, and then that is angle at center equals to 2 times angle at circumference, right? And then that angle is going to be equals to 30 degrees. Therefore, angle E1 equals to 45 degrees plus 30 degrees. And the reason is exterior angle of triangle. We know that that angle right there is the exterior angle equals to sum of interior opposite angles. Therefore, that angle E1 is going to be equals to 75 degrees.